Welcome back to my channel, and here I am going to teach you the property of integers on addition. Property of integers on addition. Okay, because the addition of integer we have studied in our last video, so here we have to discuss the properties of integers on addition, and here we have to check that what are the properties of the addition when we add two or more integers. So student, please keep your attention here and try to understand the properties of addition on integer, or you can say that the properties of integers on the addition. Okay, this is the very important topic, and you have already discussed about this in our last previous chapter, that is in the whole number, where we have discussed about the properties of whole number. And in the properties of whole number, we have seen few properties like closure property. The first was closure property, second commutative property, and the third was associative property, associative property, distributive property, identity property, and inverse property, and so on. These few properties has been studied in our previous chapter, that is in the whole number. And here we shall exact these property has been revised here in the term of integer. So student, let's without wasting our time, let's start the properties of integer on addition. So let us see. So student, let's discuss the properties one by one. The first property is known as closure property. Is closure property. The second property is commutative property. Commutative property. The third property is associative property. The fourth is identity property. And the last is inverse property. So student, here we have five property of integers on the addition. So let's discuss these properties one by one. The first is closure property. Let's see what is the closure property. Suppose that we have two numbers, two integers, 4 and 5. Here 4 and 5 are two integers and both are positive, and both are positive. So if we add these two integers, then we get 4 plus 5 is equal to 9. Okay student, here when we add two integers, we get a new number which is also an integer. Okay, so we say that if we have two integers and if we combine them with this operation of addition, then we get a new integer. Okay, so this property is called closure property. So here we have two integers 4 and 5, which when added gives a new integer. Therefore, we can say that these two numbers satisfy closure property under addition. Okay? Now, let's take some more example, like if we take one negative integer and one positive integer and then check what will happen here. So if we take minus 4 and 5 with two integers in which one is negative integer and the second one is positive integer, then we get on adding minus 4 plus 1 which plus 5 which will give us 1. And here we know that 1 is also an integer, therefore minus 4 and 5 satisfy closure property under addition. Okay, student. So I hope it is clear to everyone what is the closure property. The meaning of closure property is that if we take two numbers or any types, if we take any two numbers and the property of these two numbers are resemble to the property which to the property of the third number which will obtain after adding. Okay, so here we can see that there are two integers minus 4 and 5, and if the properties of these two numbers will be same for these three number, third number, then we say that this third number is also belong to the set of integer, or you can say that the third number is also integer. Therefore these two number minus 4 and 5 satisfy closure property. Okay, student, so this is the concept of closure property. The meaning of closure property is that if any two object belongs to the same family, then the third object which is obtained by combining the last two objects will also belongs to the same family. Okay, therefore we say that this satisfies closure property. Okay, student. Now let's see the next property, which is known as commutative property. The meaning of commutative is that rearrangement in the order of the digit. The meaning of commutative, this means that rearrangement rearrangement of digits. Okay, and we know that if we just rearrange the object from one place to another place, then its magnitude doesn't change. Okay, only its place change and its magnitude will be always constant. So here the meaning of commutative, that means rearrangement of this digit, which means that if we just change the order of the digit, the answer will be same, only the place of the digit will change. Okay, so this property is called commutative property. Now let us see this with some example. Just suppose that we have two numbers 4 and 5, both are positive integer. Both are the positive integers. And if we add these two integers, then we get 4 plus 5 is equal to 9. Okay? Here we just add 4 and 5, we get 9 as a result. Now change the order of digit, means put the 4 in the second place and 5 in the first place. Then you will get 5 plus 4, and the value of 5 plus 4 is again 9. So here when we just change the place of the digit, we see that only the place has changed. Their answer doesn't change. So we say that addition satisfies closure property. Okay, so here we say that the addition in the case of integer always satisfy closure commutative property, because when we change the order of the digit, answer will remain unchanged. Okay. Okay. Now let us see the next example with some negative integers also. Just suppose that we have minus 4 and 5, both integers. There are two integers, minus 4 and 5. And if we add them like this, minus 4 plus 5, which give us 1 as a result. Okay? In the next state, if we change the place like this, then we get 5 plus minus 1, and this will equal to 5, the product 5 plus minus 1, and when we subtract it, sorry, this will be 4, and when we subtract it, we shall get 1 once again. So here we can also see that when we change the order of the digit, the answer is remain same in case when we take one negative number and one positive number. So here we can say that commutative property is satisfied by the addition on integers. Okay, students. So I think that the commutative property has been clear to all. Now let's see the next property, that is the associative property. Let us see what is the associative property. To prove the associative property, we need at least three elements. So here we can take three integers like 4, 5 and 6. Here we have three integers, and both all these three integers are positive, and then we write them in this manner: 4 plus 5 and plus 6. This means that first we add the first two digit, and then we add the third digit in the sum of first and second place digit. And here when we add them, we get the result as 5 plus 4 is 9, and 9 plus 6, and this will give us 15. Okay, so here when we add these three numbers like this: 4 plus 5 is equal to 9 and plus 6, which give us 15 as a result. Now let's change the method of summation. Means we now in the next step we write here 4 plus 5 plus 6, which means that we have to add in the first step the last two digits, and then we add the third digit with the sum of last two digits. And let's see what answer come here. And when we add, we write 4. Just write the 4 as it is and add the numbers in the bracket. We get 11, and this will equal to 15 once again. So here we can say that 4 plus 5 plus 6 will equal to 4 plus 5 plus 6, and both are equal to of 15. So here it is once again proved that the integers satisfy associative property. Okay student, so this is the associative property. Now let us see the next is identity property, which is very important. Inverse property is not to be seen here in your syllabus. So let's see the next and the last property, which is known as identity property. In the case of addition, we see that which number should be added in 5 which does not change its value. So if we add 0 in 5, we get 5 again, which shows that 0 is only the number which when added to any non-zero number does not change the value. Therefore, here 0 is known as identity identity element. Okay student, we shall discuss about identity element in our next video once again. Till then, goodbye.